Okay. So what we're going to, so after you've unrolled your piece and you assemble it as you want it to, again, we're working from our triangulated form here. Now, I really feel it is critical that these do line up. The one thing the definition that I gave you won't do is it won't do it for all. So it might be a good start where you skip by the other surface like I did, and then you fill in the gaps, right? So you bridge the two surfaces that are triangulated. It's going to be easier to sort of assemble at that point. So that's our 3D piece. This is our laid out piece. So we're going to use curved Boolean. Let's go ahead and make new layers. So this will be let's just call this our outline layer. Make it an obvious color. I'm going to select this and type curve Boolean. Hit enter. Let's try that again. Select everything, hit enter. So you want to actually do curve Boolean first, select everything, hit enter. Let's see if we can do it without making it 2D. It should work. It's just my RHINOCAM is freaking out. Okay, so we type in curve Boolean, select all our geometry, hit enter, and then we click on the outside, and it makes a profile line, so it combines regions, yes. We don't want to delete our input. And then we hit enter. So now this is created. I forgot to make that layer current, so make that new layer current next time. We'll switch it. So now there's a magenta line. That's our profile line that's running along the outside, okay? So this is going to be our cut line, basically. All right? Now the next thing is, if I want to define holes along the edge, a couple ways we can do this. We can do it manually, or we can write a real quick Grasshopper script. So let's write a real quick Grasshopper script, because that's going to be easier. So we're going to do new. Now the one thing is, I can take this now and copy it. So that's our profile. What we can do with this is actually explode it. And the reason why I'm exploding it, because I know certain edges are potentially open edges that don't attach to something. So let's assume I know this edge there doesn't need zip ties because it's an outside edge, right? It's not an inside edge. Does that make sense? So all I want to do is add perforations to those. So I'm going to go ahead and rejoin that. So I have that as a separate line. I'm then going to come in here and go to curves under geometry. Right click, set one curve, pick that geometry. So that's embedded now. And then we can look at some curve options. One option, we can do a couple things. Let's just try offset. Let's see how that works. Offset will do our offset. If offset doesn't work well in here, we'll offset it manually. So that's our offset. It's offsetting in a certain distance. This is the tricky part now, because we really don't know what size this is going to be right off the bat, because although it's going to be eventually to a scale, we're going to determine that on the large one. On this test one, I'm not really concerned that it's at a quarter inch or half inch equals a foot. We'll do that for the final one when we put people in it, right? So we'll be more conscious of how big we can get it. The offset distance right now might need to be more visual, okay? And what I mean by that, we want to make sure we're offsetting the line a certain distance. And that distance might be really large. So I'm going to make the 0 to 100 as my number slider. Plug that in for D, and then we can start offsetting this. Now you can see it's offsetting on the outside. We want to offset it actually to the inside. Okay. So we can edit that, make it a negative 100, and we offset it to the inside. So 100 what? I don't know. Well, you can see we're also having an issue when we offset it too far, the two are colliding. So this is where we might need to break this into two. Okay. So I will join Alright, so let's just look at this for now. Now we have this offset curve, and basically what we want to do is now put points on there. The points are going to be what we reference in the CNC machine as drill points. So those will be plunges. Okay. Now the tricky part is lining up the holes with the other parts of the pattern, right? So we have a couple of options that we can use, and that's going to be under our division, curve division, we can divide by a distance. So we want to divide typically by a distance or length. So this is creating a point by distance. And we have to be in the positive. Oh, and I'm probably going to try not to crash this. So again, my thing is scaled like crazy large. So let's go ahead and open this thing up. Alright, so this is representing a distance from a start point, okay? Now, the reason why distance will be more critical and eventually when we scale this down, I guess the big problem is going to get to line all these points up, right? So when we punch holes, that they're in the right position to the other. That's the tricky part. By using distance, we know it's always a certain distance from one edge. The problem we're gonna run into is when it comes into here. So basically what it's gonna work out to be, guys, we have to really explode and probably do each line individually. Because this edge here is gonna line up with the other edge. So if I join this, and I know we're always starting from the top and going this way, we'll be in good shape. Now this hole won't actually do anything, so we could look at starting this further in. Length will give us the same thing, will be the length of the point. I wonder if we can... Yeah, I think we're just going to have to deal with having our start point there, and that's fine. So what we can do is if we did the other line here, it would be basically the same distance. We just have to make sure it's starting from the same point. Now, we can see this happen easier on this edge. This edge here aligns with this edge. All right? Those come together, we know, because we can see it. And we know this edge is going to come together with that edge. All right. So let's go ahead and join that. And we're going to let's just set that one for now. So we can see it starts that way and goes in this direction. So we have to make sure we're going to join this. Join that. I'm going to then also, let's set multiple. We'll pick that and that. And we can see this is starting in the wrong direction. You see how this is starting here, but it needs to start at the stop, at the top. So we're going to flip this. Type in the flip command. Now that's going to lead to another issue. It's going to want to offset on the outside. Okay? So this is where we want to copy this and do it individually. So we'll set one curve there. Let's set one curve here. Let's make our offset negative 100, and we'll make this positive 100. So these holes now should line up. And if this distance was like, let's say we're working in millimeters. So now the spacing of these should be in identically in the right position. Like that is there. We're getting an extra one here just because of the way the offset is. Okay. So when we put this together, the holes should be in the same spot. So the key is that this is moving in the same direction. Now, can we do this manually? Of course you can, but it could be faster if you're using the same size and you're just plugging in, because then what you're going to do is just bake the points. So I'll make a point container. And I'll just bake the points. Put it where outline is. And then I have those points as reference. Okay? So we need points for the plunge. Okay? Alright, so let's draw this line back. And then I can go ahead and join this entire thing. Alright, so this is our cut, and then these represent plunge points, drill holes. Okay? That makes sense? So far, so good? Alright, so the next thing is we have to, after we do this, we have to understand scale. We're going to double check our units. We're in inches, great. We basically are going to make, real quick, a curve, rectangle, corner, 0, 0 to 48 inches, 48 inches. That's how big your sheet is going to be. And you can see we're way too big, right, scale-wise. So once you have all your pieces, you're going to want to take these and copy them. And then you're going to want to scale them all together at the same time, so you scale everything. I don't have all my pieces, but I'm assuming this is what I want, right? So I'm going to take this and scale it way down. And I'll maybe just select these, do an invert, hide. So I'm just working with my new geometry. And we're basically just trying to make it as large as possible. Okay? Now you're going to have probably other pieces. Right? You're not going to just have one piece. So making one large piece becomes problematic because you'll run out of room, right? So for this exercise, I want you guys to make this stuff as big as possible. Okay? Get all your pieces on this 48 inch by 48 inch. Okay. So far, so good? So this is 48 by 48. I have all my cut profiles. I have potentially my plunge cuts. You want to make sure these line up so when we fold this thing together, they're in the same position, especially when we're zip tying them. You can also just thread it and tie a knot. That also works, right? So I'm like, yeah, or I won't select them, but I could just delete them. Yeah, because we don't want to be plunging and we don't want to waste time on the machine. Right? So those are my drill points per se, okay? So this is my setup. I have all my patterns. I have holes where I want them. And now I'm going to go to RHINOCAM. Okay. Let me just do a save as real quick. RHINOCAM looks like it's not going. Okay, so you go to RHINOCAM and you're going to go to Machine Operations. Okay, so this is where we're going to start to make the cut files, okay? So we're going to be working on 2D axis, X, Y. We're not going Z. So this is our 2D. Under Post, the first thing we're going to change, we're going to click on Post. And we're going to set our current post processor to the longest Shop Sabre Win CNC ATC. So for those of you that were authorized in M&M, that's a different machine. We're using this machine. It's actually on the list. So that's the one that's in the idea shop. This is critical so that the NC file that's generated is specific for the machine, because the G code, certain commands, certain machines have different responsibilities, like tool changes and so forth. So we have to make sure that's the first thing we change. The next thing is we're going to set up our stock material. So we're going to come to stock and we're going to go to box stock. This is setting up our material. Okay? I always set it up that we're cutting down. So 0 is the top of our surface and we're going negative into the material. So 0 is the top. So we're going to pick this button here on the top, which puts at the Z at the top of our material. The other thing is our material height is going to be 0.04. And then our 0, 0, this is going to be 0. So it's all going to be 0, 0, 0, 48 by 48, a height of 0.04. Okay? And then we're going to hit OK. This generates the material. And I think there's a way to always have the material on. If we go to simulate, that's our material, okay? So let's go back, let's go to program. There's our part. So the first thing that we're going to do is create a 2-axis cut. And what we're going to be doing is called profiling. It's a profile cut. Okay? So that's going to draw a profile along. So we go to profile. What it's looking for is what your sort of edge condition is. So we select our region, which is going to be that edge, and hit enter. So that's our cut region. The next thing is we have to define the tool. So we're going to go to Tools, Edit, Create. And then we're going to pick a flat mill, and we're going to use 1/8 of an inch. So 0.125 is going to be the tool diameter. Okay? So we're using a small down cut flat mill bit. Hit OK. So we have our tool. Feeds and speeds. This is going to be how fast the actual spindle goes. And then these are how fast this thing is moving over the plastic, okay? If we go load from file, sorry, not load from file, load from tool, hold on a minute. It's load from file. So we're going to go from load from file. If we put our spindle speed at 6,000 RPM, and then our cut in inches per minute at 60. All right, 6,060, hit OK. This will change our spindle speed and then change all our plunge and cut speeds. Okay, relative. So we don't have to set these in manually. We can go to load from file, put in our spindle speed of 6,000, our cut feed of 60, hit OK. And I'll put all the proper speeds. Clearance plane, just leave it on automatic. We don't need to change anything here. Cut parameters, we don't really need to change anything here yet. Cut level is critical. Our total cut depth is going to be 0.04. That's our total cut depth, 0.04. Okay? And we're at the top, so we're cutting down. Entry is like how the thing comes in and out. We want none and none. If we're cutting like aluminum or some type of metal, the blade needs to typically come into the metal a certain way, otherwise it trails tracks on the material and then launches it across the room. So none and none. Advanced cut parameters. We're going to do some bridging, although the bridging probably won't work that well. We'll do a bridge height of 0.04. That's how thick our material is. And we'll make our bridges like 1 inch long. So this means it picks up and leaves some material behind. So as this thing's cutting out, eventually there's nothing holding it in its spot. Right? So if we give it some bridges, some lengths, and say we give it a total of 8, it's going to leave these parts of the material there that we can come back later with an X-Acto blade and cut it out. Right? So we can save that. If we right click and we say, if we come here and we right click and say regenerate and hit OK, it's going to generate the cut file. So this thing is generated now, the profile cut. We can't see much other than we can see the tool path. It's good because it's on the outside. This is how thick the tool is. That's why the path is 1/16 of an inch off to compensate for the thickness of the bit. This thing will roll along, all along here, and make its cut. If we go to simulate, and we play it, that's the cut out of our material. Okay? So that's basically what we're doing. Okay? The next thing now is we're going to go ahead and program holes. So we can drill a hole. Okay, that's what our holes are. Now we're not going to use a drill bit. We're going to use the same tool, but we'll use drill. Drill is looking for the drill points. So we're going to select drill points and we're going to pick our points. And hit enter. Okay, that's our region. Our tool is we're gonna make an edit We're just going to do, these will be again 1/8 of an inch. So we use a drill, tool diameter 0.125, save as a new tool, hit OK. Feeds and speeds, we're going to leave what we had before. Clearance, we don't have to worry about. Automatic. Cut parameters, drill depth, 0.04. Okay? That's how deep we want to go. If that's like 2 inches, you will drill a hole into the deck of the CNC, and John will kick you out of there. So we're always going to verify these, but short, we don't have to worry. We can just say generate. These are our drill holes. So it's going to come here and just drill a hole. Drill a hole. So we have 2 passes. Now I would drill the holes first. So if we come to simulate, it's going to come and drill the holes, and then we would cut the profile out. Okay? Because we don't want to drilling holes on something that might be really moving on us because we just about to cut it out. So you typically want to do all your detail work, like when we do the pattern cutting on this, and even if it's just going to be surface cutting, like we won't cut all the way through it, we're going to make sure we're doing that first, because later, and then we'll do the last cutout last, right? So we can post these separate. So what we're going to do is, my standard drill, I'm going to right click and go to post. Post is going to go ahead and create a new file for us. We will call this, okay, week11 standard drill, that's fine, we'll post it. This is the file. This is what's going to run to drill the holes. This is what G code is, yeah? The one thing we need to eliminate is T. T is the tool. So there's a tool changer on this thing where it can go and grab a tool. We're going to do that manually, and we're not going to be changed. So we delete the T and we resave it. Okay? We're then going to post the profiling. Post it. There's also a T. I'm going to delete that. Then what I can do is actually take all of this, copy it, go to the first one, run this first, come here, paste the next one, which is the profile. So it's going to do the drill cuts. This is what the machine runs with just through Notepad, guys, just through a bunch of commands like go, G code, go code. Telling it, starting up the spindle, 6,000, moving it up in the Z, 0.25. All right, this is just telling this gantry to move, yeah? So I have both cuts. So I have the holes being drilled and then the profile in one file. I can save it. This is what we're going to then open up in the lab on the machine. Double check everything. Make sure our Z heights are right. We'll see a lot of what's happening pathwise, and we'll look at what our Z is. Z is always the critical, because if we go too far in the X or in the Y, there's stops that will stop the machine before the thing explodes. And then we'll run it. Okay, and it'll take about 5 minutes to cut. It won't take long for us to cut. It's going to get more complicated once we start doing complex patterns on the surface, especially there on fully depth cuts. So the idea is that you cut your pieces, you take them with, you put them together, bring them in on Wednesday. Okay? So on Friday when you come, my advice is to have this. You can do all this coding, all this work here in the lab. Okay? The lab computers have RHINOCAM. You're going to have to bring your file with, so make sure you have your file with, and make sure you saved it down to R4. The lab and the Idea Shop just has Rhino 4. So you'll take this file and go File, Save As. And you'll save it down as Rhino 4. Okay? Bring it on a jump drive, put it on the Google Drive, whatever. We're going to open this up on the lab computer and just double check it, post it again. But I want you to have these ready. All right? And then I'm going to double check everything. And then we'll post it, and then we'll start cutting. Okay? So please sign up. Hopefully we can, there's enough slots basically to get like 32 people. We're less than 32. Just try to get as much done as we can on Friday. I'll bring zip ties with. I have a whole bag of zip ties. I probably won't have enough for everybody, but we can test. We'll test the first one to make sure it's working as we think it's going to, which I'm sure it will. Zip ties you can buy at Home Depot really cheaply. Like I would get the little ones, but let's test it on Friday and I'll shoot you guys an email. All right? Questions on this?